So, you want to be a teacher and a successful one? One of the most famous approach to successful teaching is the constructivist approach. In all my years of teaching maths, science, and even music, I had no idea that I was actually using the constructivist approach. After doing some research on the constructivist approach, I realized that I owe my success as a teacher to this approach. I always love to pose questions and problems to guide my students to find their own answers instead of just spoon feeding them. With this, I also like to prompt my students to formulate their own questions and allow them to have multiple interpretations and expressions in learning. I am also an advocate to group and teamwork, at which students will use each other as resources. So, how can I apply constructivism in the classroom to create a better teaching and learning process? So, what I will do right now is I will divide this concept into 6 characteristics of constructivism and its application. So, number 1 is to construct knowledge. Firstly, my students are not blank slates. They come to me with already formulated ideas and knowledge and understandings. And this previous knowledge that they have is the precursor for the new knowledge that they will create. So, for example, I will post a question when I'm teaching maths, right? I will post a question of how to measure a length of a bus. Instead of giving my students a method, like example, use the ruler, I will allow them to reflect and construct their own methods of measurement. Some might say, "Sir, can I use the ruler or measuring tape?" Others might say, "Can I use feet, as in use my feet and measure?" So I will prompt them, I will prompt my students to discuss methods that they have heard about, or even come up with their own methods. And then you make mind maps of different kinds of methods of measurement that can be applied. So this is how they can construct knowledge. Number 2, I want my students to be active. My job is only to coach, moderate, and to suggest. I want my students to actually experiment, to ask questions, to try new things, whether if it works or it doesn't. In short, I want them to be active and to have full participation, like when you have on hands-on experiments. This is an important part of the learning process, and it makes my students to reflect on, to talk about whatever activities they're going through, and also not forgetting the ability to assess themselves and to set goals. For example, role playing. I love to use role playing in my class. In teaching science, especially earth sciences, I will get each student to kind of like take a role of people who are affected by earth sciences issue, such as like volcanoes, tornadoes, or polluted lakes, and ask them to study the impacts that these earth sciences issues have on human life, or the effects of human activities on the world around us from the perspective of their role-playing person, from that person that they're being assigned to. So students will be able to explore scientific data through different perspectives and be able to debate about it by having role-playing. So this is how they can keep active and they are having active participation in class. Number 3, I want my students to be able to reflect right here. I love my students to have control on their own learning experience and own learning process and reflect on their experiences. This process makes them experts of their own learning, and as a teacher, I create situations where they feel safe questioning and reflecting on their own knowledge and on their own learning process. It is important to talk about what was learned and how it was learned. For example, let's say when I'm teaching science, after I complete a chapter, example, the chapter of the human heart or the chapter of blood circulation, um, I will usually divide my class into groups and I'll ask them, guys, prepare a presentation on what you have just learned. So they will need to reflect on the topic and figure out the best way to teach the whole class on the section of the chapter that they have been assigned to, for example, human heart. In other words, they will actually become teachers for one day in teaching each other. And I will encourage them, as a teacher, I will encourage them to be as creative as you can be. And in their presentation, whatever way they want to present, be as creative, and I will not stifle that creativeness. So hence, they can reflect and learn in a fun way. Number 4 is to collaborate. To collaborate. I am really big on collaborative learning in my classroom. I've found that my students learn about learning not only from themselves, but also from their peers, and this allows them to pick up strategies and methods from one another. They will also be exposed to different points of views, which enhances their learning experience. So for example, let's go back to earth sciences. If I'm teaching the earth science again, I will probably take my students on a field trip to a nearby bushland or to a nearby taman to conduct scientific investigations aimed at observing, collecting, and recording data of how different trees, example, how different trees grow in the habitat. If there is a chance, maybe we can also study how different animals interact with one another, with each other in that certain habitat. So students will have to work together to observe, to investigate, and to collect that data. And I love the way how this can really bring them together in trying to form different ideas and point of views, but arriving at the same kind of objective in collecting that data. Number 5 is to inquire. To inquire. Part of the way I teach is by making my students inquire information in the quest of solving problems. So my students use inquiry methods to ask questions, to investigate a topic, and use a variety of resources to find solutions and answers. As students explore the topic, they will draw conclusions, and as exploration continues, they revisit those conclusions. And usually, exploration of all these questions will lead to even more questions. For example, let's say if I'm teaching the topic on purifying water and water purification in science, my students, in figuring out how to purify water, will have to investigate solutions ranging from maybe coffee filter paper to stovetop distillation apparatus to piles of charcoal to an abstract, maybe mathematical solution based on the size of a water molecule. All of this is just how to figure out how to purify water. So depending on their responses, right, I will encourage abstract as well as concrete, poetic as well as practical creations of new knowledge to help them. This will lead them to ask even more questions and be more inquisitive. Hence, their knowledge will be enhanced, and they will find ways to figure out how do we arrive to the solution. Number 6, and the final characteristic, is to evolve. I want my students to evolve. So, sometimes my students have ideas that they may later see that was actually valid or incorrect or even insufficient to explain their new experiences. These past ideas are actually temporary steps in integration of knowledge. So, what happens when a student gets a new piece of information? Usually, number 1, when the new information may match up with their previous knowledge, right, pretty well. They may match up. So, in other words, it's consistent with the previous knowledge that they have. So, the student will tend to add this new knowledge in their understanding. Or maybe the previous knowledge doesn't match, and the student has to change his or her previous understanding to find a fit to this new information. Or in some cases, they might even just ignore it. So the rejected bits of information may just not be absorbed by the students, or they may just float around, waiting for the day when the student's understanding has developed and permits a fit to this new information. Okay, for example, let's say I'm teaching gravity, okay? And I believe that my students already have an idea of what gravity is. So I will create an environment of discovery with objects of varying kinds, different kinds of objects. Students explore the differences in weight among similar sized blocks of like styrofoam, of wood, and even lead. And some of my students may hold the notion that heavier objects will fall faster than lighter ones. Then I will provide materials such as like stories or like posters or even videos about Galileo and Newton, the guys that were discovered gravity. This leads to a discussion on theories about falling. So my students then will replicate what Galileo did in his experiment by dropping objects of different weights and measuring how fast they fall. In the end, they will see that the objects of different weights actually usually fall at the same speed, because why? Gravity is the same. Although surface area and aerodynamic properties can affect the rate of the fall. So they evolve. They just evolved. So now, to conclude, in other words, the 6 characteristics that I will infuse in my classroom. Number 1, as you can see, I will integrate the act of learning to construct knowledge. Number 1. Number 2, to be active in class. Number 3, to reflect. Number 4, to collaborate and to work together. Number 5, to inquire, ask more questions. And the last one is number 6, to evolve. And these constructivism characteristics will truly enhance my students' learning experience. So I hope it has been a help to you as well as a teacher, if you're planning to teach. So let us really appreciate this vocation of teaching that we have in order to create a better future for our students. So thank you.